Hello, everybody, and welcome to Wow 11. We've got a special presentation in store for you today. So today's presentation delivered by Chris Klosterman, Assistive Intelligence Integrate domain expertise and technology to improve results, is coming up next. So if anybody has any questions for Chris, go ahead and drop them in the question panel that's somewhere on your screen there. And we'll be sure to answer your questions if we have some time towards the end of the presentation. And to get us started, you may have seen, and if you haven't and you're in our live audience today, KIIoT is giving away a $10,000 maintenance assessment to one lucky attendee from today's webinar. So that could be any of you. So that being said, the final step for you to take to complete your entry for the giveaway is to go ahead now, find that Q&A panel, drop in your location. Doesn't need to be super specific. We're looking for like a state, country, anything like that. Drop in your location, where you're attending from. We always love to see that. And the guys at KIIoT will be in touch later today or tomorrow with their selection of who the lucky winner of that maintenance assessment is going to be. So go ahead and do that now. And that being said, I'm going to bring on the man of the hour, Chris Klosterman. How's it going?
Very well, very well. Hope everyone's doing well today on an early Monday for some of us.
Right? It's a great early Monday to be here with you, Chris. So I'm going to go ahead. If you want to get your screen ready, we'll go ahead and we'll kick things off as people are still submitting their locations here. We'll let that go for the whole presentation. And let's get you all set up here. So we should be getting your screen shortly. Let's see here. A moment to load up. How's the weather where you're at, Chris?
It is a balmy 100 degrees.
Oh, lovely.
So
we love that.
We're having fun.
Indeed. No joke about that. I'm pretty sure that we're having the same here in Fort Myers, Florida. You step outside and it's just like a warm hug.
A hug is a nice way to say it, I guess.
We're keeping the positivity here on a Monday morning, Chris. All right. So it looks like I've got your screen, but it looks like some behind the scenes stuff, which I'm not going to put up there for everybody to enjoy just yet. Wait on your presentation. Let's see. We practiced this. Chris, what happened? The Monday morning got us.
I don't have the share options that I had just a moment ago.
Goodness. All right, let's try this again. Folks, you didn't know you were going to get a comedy show today, but I tell you, you are in for a special one. No doubt.
We hope to keep it light here, and
we do
make fun of ourselves more than anything.
Exactly. What is life without that, honestly? Did you find your presentation?
Well, I have the presentation, but I can't see you. But
all right. Well, I think here we go. We've got a presentation that looks that. All right, Chris, it's all on you.
All right. Well, again, thanks everyone for joining. Pretty excited about this. Again, if you have any questions, it's kind of hard to make this interactive, but we'll get to all the questions that we possibly can and look forward to those. So again, my name is Chris Klosterman. I am the owner and founder of KIOT, or K-IIoT, and really want to talk a little bit about some of the things going on in the industry today, and specifically around the condition monitoring space. There has always been a lot of turmoil with a lot of us old guys of, is it condition monitoring or predictive maintenance, and what do those terms mean? I've actually sat in debates for 2 or 3 days going over some of that stuff, and we're going to make fun of that and talk about it a little bit, and then really get down to what do the words mean. But for this conversation, condition monitoring, under the premise of predictive maintenance, is the leading IoT case for digital transformation. And there's a lot of buzz been going on out there for the last 2 or 3 years. And people are having varying degrees of success. but there's a ton of confusion, and we'd like to talk about why and clear maybe some of that up, or at least start an interesting conversation regarding that. So we're going to dig into the why and look what we call assistive intelligence or assisted learning models. But I like to define a lot of these problems a little bit moving forward. One of the biggest things that I see is just so much marketing BS, and that BS is buzzword salad here. We feel like we see a lot of people in the industry creating made up words and using a lot of the old terms with new definitions, which is creating again some issues. For those of you that don't know, IIoT it stands for the Industrial Internet of Things. Industry 4.0, smart manufacturing. There's all kinds of words that get thrown in here, but we're really trying to accomplish a lot of the same things, which is have one version of the truth with a massive set of data. And then our job is to analyze that data and turn that into valuable insights, which for those of you playing buzzword salad bingo, insights is one of our on our coverall here. But again, we talk about predictive maintenance, and that term is being thrown around a lot today, and it doesn't necessarily mean vibration analysis, condition monitoring, thermography, ultrasound, all the other terms. A lot of how people are using that term today is really predicting or calculating when a failure may occur. Whereas condition monitoring, we're really determining if a failure or failure mode is present in the asset. So we're not predicting or modeling that a failure should be happening by this time. Condition monitoring is really solely based on data and making your decisions based on that supporting data. Another term out there, we hear so much about smart sensors. I have a number of sensors. A lot of what I do is focus on the sensor area and test those sensors. I haven't seen a smart one yet, to be real honest with you. But when you hear the term, it's related to generally that sensor are devices which generate the data and do some type of calculation at the edge or give you some type of analytics from that sensor. Generally, that's typically based on, again, edge computing, but they're really focusing in on the calculated scalar values and trying to glean some insights into that. And we'll get into some of that a little bit further. And again, insights, I don't even know what that means anymore. I cruise a lot of people's websites and are constantly reading about the space. And the term "we provide valuable insights" keeps being used, and I'm starting to use it, and I despise the word. So I digress a little bit. But with all the buzzwords and the hype that's going on, that's getting a lot of attention from the C-suite, and it really, really begs the question of why are these initiatives failing? And why are people struggling to try to get them off the ground? And what I see is it really comes down to lack of definition or poorly defined definition of what IIoT or digital transformation means for that organization. And it could very well mean something a little bit different for everyone. Different initiatives may be more important than others on that journey. And we're going to cover a little bit of that. The other thing that we really run into is existing infrastructure and some of the complexities to share this data, whether it be wireless, on the edge data, whether it be in a cloud or on a server somewhere. Getting additional sensor data on those networks, storing that data and repurposing it really adds a lot of complexity to the IT community. And then probably most importantly, is just the whole overpromise and underdeliver side of what IoT is going to do. You know, we read, like I said, constantly, and see CEOs talking about to Wall Street what these initiatives are going to bring to them, but yet they're not defined. We go back to the first thing that we were talking about here. That definition is so important. McKinsey says roughly 2 and 3 transformation initiatives are failing, and it's likely a higher number. And there are some reasons why. You know, this is not a project; it is a journey. And treating it as a project means it has a beginning, it has an end. This is about improving and not hitting a timeline. And sure, there are projects along the journey, and each one of those are very important and very relevant. But keep in mind, the promise of this was to bring all this transient data out there and to be able to analyze that and provide insights that otherwise human individuals may not derive on their own. You know, that's the promise of machine learning and really how it's used in some really good cases. But if we really think about what good looks like at the end of the journey and work our way back to help define those steps and define what does this mean for our organization? Where are we going to get really the best bang for our buck is super, super important. So as I go through doing my research and furthering my education, I'm looking at a lot of the vendors and the large guys and what they're promoting and what they're saying on their websites. And some of it actually gets kind of comical. There's all kinds of cool catchphrases out there, especially in the sensor world. It gets interesting. You hear things like an end-to-end solution. Boy, if we can't define what IoT means or digital transformation means to us, an end-to-end solution sounds really cool and promising. You hear terms like plug and play. I've installed thousands of sensors, and I've never plugged one in and walked away from it. So there's effort there. Please don't get caught up in some of these terms. That's why I'm sharing. You know, no sensor knowledge needed. Do DIY, do it yourself. Stick it on there. And as you technical folks know, that's problematic. Knowing where to place those sensors, understanding the components and the assets that are there is fundamental. You have to understand that to know whether you're getting proper data, to know whether your amplitudes are meaningful or not. And you know, another one that I love is our sensors, our tech will solve your problems. I'm here to tell you that sensor, if you install it, is not going to solve your problem. It is not. It may identify a defect, and it may be the best tech out there to do that. But your problem today is probably not, can I obtain good, reliable data? Your problem is probably a lot deeper than that. So, again, I probably have 300 sensors here out up above me. Not one of them solves my problems. I've talked to them. I've begged them to solve my problems. They don't do it. Another good one, you know, these sensors increase your safety and throughput. They can provide you data and insights. I use the word insights to allow you and your organization to modify your behaviors, identify potential issues, but you have to do something with that data. So a sensor does not a sensor alone does not increase your safety. It will not increase your throughput, and it will not solve your problems. And that's something that I really dwell on. I'm not going to read through the whole list here, but another one that I will hit on the last one of continuous 24/7 monitoring. I get this question a lot in my business of people say they want continuous data live time. And that live time is a real interesting conversation because you are not going to get it at subsonic speeds. You're not. It's depending on the tech. And for those of you that are listening in that are really looking to evaluate sensors and what you need, most of these wireless systems, by the time it gets the command to acquire the data, to send the data to the cloud, to get it back to you, could be 3-4 minutes. So be careful and really ask questions around what does live time really mean, because it is not always the same meaning to everyone. Now, there are systems out there that will give you that lifetime data, or lifetime data acquisition, and it will be sub-second. But be aware there's some things there you need to check into if you're looking for those type sensors. So let's talk about what really is needed, in this new age of IoT, digital transformation. And I will contest to you that the laws, the mathematical laws have not changed, nor the laws of physics, nor have the rules of acquiring good data. Foundational elements are required if you truly want to make a difference and see value long term. Simple things like functional location hierarchies, getting information, down to the level that you need. And we're going to get into some of that in a moment. But again, these initiatives alone, installing sensors, as we just covered, are not going to solve your problems. Having a good work management system and a good process in place that allows you to identify the defects, plan and schedule the elimination of those defects, and your continuous improvement loops is really, really, really how we improve things, especially in the maintenance arena. And we're going to talk a little bit about bringing process data in and the difference between asset health and process health and the synergy of those things. We're going to get into some of that later. But at the root of being able to do all of that are your foundational elements. There's no getting around it. There are no shortcuts. There are no whiz bang sensors or tech out there that it's going to allow you to take poor data and poor processes and add value at the end just by doing these initiatives. So I really, really want to stress that. If you take nothing else away from this conversation, please take that away and really think about that. And we'll get into the data part of that to why these are important. But I wanted to pop this up here to just kind of get the juices flowing and thinking about, do you have foundational elements in place? Do you have good systems and processes in place to be able to utilize this mountain of data and knowledge from the data that's going to be coming your way? And if that is broke, it's going to be extremely frustrating and your ROI is going to be greatly diminished. But right now we're going to really focus on, the CBM analytics side. We'll get into some of those details now and kind of the whole purpose of this conversation. So getting into the data side, you really, really need to have the detail level down to component, to each individual component and part within that component. So when we're talking about doing analytics, whether it's through machine learning, AI, whatever it may be, you must have this information. Things like the running speed of the assets, and in today's world with all the VFDs and things going on out there, that's a difficult thing, but we must have it for our calculations and things to work here later on. Things like knowing the number of teeth on a gear, the number of impellers on your fan or in your pump, your bearing numbers. If that information is known, we don't have a machine learning problem. We have a math problem. So understanding those things, it becomes pretty straightforward math, really. The underlying principle of having that data and information is having a fundamental understanding of how do these components behave, and what are the failure modes. I'll call them the engineered failure modes. In other words, how can these assets fail? How can these components fail? One of the things in one of my previous lives in my career, I was managing multiple engineers across the globe. And it was always frustrating to me that I would ask someone what they were working on a particular project. And I would hear, well, I'm doing a failure modes analysis on an ANSI centrifugal pump, or we're doing an RCM on this particular pump and system. And the next week I would ask someone halfway around the world, what are you working on? And the answer would be, we're doing a failure modes analysis on an ANSI centrifugal pump. So there are ways to database that, and I'm not going to go into that, and I'm not going to try to sell you guys, but there are databases out there that you can get to really get you a long way down the path, an 80% solution to here's my asset classes, my component classes, here's the methods in which they fail, here's the failure mechanism, the failure reason, and what technologies can identify those failure modes. So we should really think about our strategies, even our IoT strategies, from a little bit of an RCM perspective of what is the function of this system or even this component, how can it fail? And if I can understand those things and I have a good failure mode library to fall back on, understanding what to measure, how to measure, and when to measure become an exercise that's not difficult. So we don't have to guess. Everything should really be driven from a failure mode perspective. Further talking about that, vibration analysis has long been thought as the heart of condition monitoring program, and depend on what your primary asset base is. But for rotating assets, we'll let the industry speak for themselves, and that's what they claim, and I'll agree with it. But what's really required to enable a good program, and that's kind of what we're talking about here. And again, it's the foundational elements. How can the equipment fail? What are the parts and pieces inside of these things? And having the domain knowledge on your staff to understand what does cavitation look like in an FFT? What does it look like in a waveform? If you have that domain knowledge, creating an assisted learning model to actually go out and identify those defects for you, is again, it's a math problem. It's not a machine learning problem. And we'll get into where machine learning is going to be a wonderful tool for us here in a moment. But to identify these defects, these engineered failure modes, it's quite simply a math problem. And if you have the domain knowledge or the expertise on your staff, those folks should be involved in setting up these programs. Their knowledge is invaluable to you. Breaking that down a little further, we talk about really understanding the individual failure modes inside the components. So an AC induction motor is made up of specific parts, and every AC motor is going to have these parts. You're going to have your bolts, fasteners, your cooling fans, your electrical windings, motor housings, blah, blah, blah. I'm not going to read all these to you. But it's important to understand the parts and pieces in there, again, to understand how they can fail. If you understand those things, then sensor selection, what type of sensor, what requirements from those particular technology sensors, becomes a math problem. And that's something that, again, if you have the domain knowledge and expertise, you have vibe analysts or reliability engineers that understand these things, building your smart systems, you really need to bring those folks to the table with this knowledge to work with your development teams on these initiatives to write out, these assisted learning models. Once we break down the individual parts, we really get talking about what are the failure modes and mechanisms, or how can the equipment fail, and what are the reasons for that failure. So if we look at a rolling element bearing, this is just an example, and it's not meant to be a complete example, just an example. If we look at a rolling element bearing and an AC motor, there's a list of specific ways that can fail. And there's specific reasons for that. So you can have adhesive wear due to improper lubrication. If I was going to design a program and I was really concerned about those particular failure modes, I would probably look at my lubrication program, what the analysis would be, what sensors I need, or maybe it's just a PM inspection to make sure that I have those failure modes covered. It's extremely important. Where I see a lot of these initiatives failing is we want to start with technology and add gadgets to this, say we're doing IoT, but we really don't know why we're placing the sensors, what sensor types we need, what the capability of the individual sensors may be. There's nothing wrong with some of these wireless sensors out there. The MEMS technology is getting very, very good. But if you have to look at a Syntax air compressor with running speeds up in the millions, that tech's not going to cover those failure modes for you. You're not going to be able to see your gear mesh and some of those things. So starting with the foundational elements and understanding the failure modes within your assets is brutally important. Otherwise, we're guessing, and we're throwing tech at it just to say that we've done it. And again, if the individual parts within the components are known and the associated metadata is obtained, it's a simple math equation to identify whether that failure mode exists or not. And notice the word "and" in there. A lot of us stop very short of that and do not acquire that data, and then we rely on an individual in our CBM department to come up with that, and a lot of times that's just not fair. And again, it's simple math. It's really to identify these things. We're not overly concerned with a machine learning problem or getting some new whiz bang tech from an ML side, a true ML side, as much as creating smart systems with domain experts that understand that math equation. Okay. So we'll talk about what is this simple math? How do we get there? What does that mean? So I used the word metadata a moment ago, and just to make sure everyone's clear, I'm really talking about the make, model, manufacturer, serial number, RPM, bearing numbers, that type of level of detail. Is if that is obtained, then the math problem becomes somewhat simplistic. It really does at the end of the day. So I'll talk a little bit of really what are the differences here in a lot of these so-called smart systems, or what we see being the commercialization of it being thrown at us of analytics in a box. Generally, what you're going to get are those calculated scalar values, which is equivalent to your check engine light in your car. I think everyone has seen that. And if you think about it, if you're driving down the road and your check engine light comes on, the first question that generally pops into most people's mind is, what now? What is the problem? because check engine means a lot of different things to a lot of people. To my wife, it means open the hood and look to see if there's still an engine in the car. It doesn't give us the detail that we need to actually have actionable circumstances around that. Whereas if we have waveform data and do FFT analysis, we can not say check the motor, check the pump. We can get down to, is it an imbalance issue, misalignment, looseness? What is the individual failure mode? And a lot of times the reason for that specific failure mode that allows us at the end of the day to dispatch maintenance, get the job, get the information to a planner where that job can be planned, kitted, and we can go do things the right way. And again, it's really the difference between a check engine light or, hey, it's vibrating more than it was yesterday, versus prescriptive analytics and specific recommendations to be able to go execute that work order and eliminate that potential defect. So that's really where we're delineating things here. For you CBM analysts out there, I hope some of you are shaking your head and nodding here going, yeah, we've been doing that all along. Yeah, we have. The good ones anyway. We've been doing this for years. We understand the failure modes in those assets. We understand the math. We understand how to derive that from a waveform and an FFT, but we've never been the cool kids. So I would challenge you folks to really embrace a lot of what's going on, and be careful about patting yourself on the back too much. But we really have been doing this for many, many years. And it goes back to a little bit of my marketing buzzword salad comment of, in a lot of ways, these things were being done in the 1970s, 1980s. I'm going to show my age here. Now we put a new skin on it, a new acronym, and it's cool. So embrace that, take advantage of it, and let your organizations know you have that domain knowledge, you have that expertise, you have something to offer the world when it comes to digital transformation, and specifically around the data analytics side for the number one use case for IoT, which is condition monitoring. Okay. Jumping into the ML world, machine learning is really utilized when a human person doesn't know the algorithm. There's so much data, it's not linear, and there is no math equation to solve that problem. ML is a wonderful tool for that. But when it comes to defect identification, we know the math. In most cases, at least 80% of the time, we know the math. So again, for you guys that are out there that are practitioners, yeah, I'm going to give you 20% of the time. There's a little bit of art, and there's a little bit of feel to it, and there's expertise and years of experience that go into some of that. But 80% of the time, man, it's a math problem. It really is. So think about what you could do with that. That's really one of the key takeaways here, I hope. In order for machine learning to actually work, it must see what failure looks like, typically at least 3 times. So you will hear, oh, we need data. We need data. The data scientists will say, we need more data. We need to see examples of that. Well, that's cool, but I have never ran across a customer or a client that would allow a piece of equipment to fail 3 times per failure mode just so I could learn what it looks like. And that's not a joke. It's not going to happen. It sounds funny, but that's really what we need. Now, if it happens to fail and you happen to have the data, you can feed the model to come up with what imbalance is going to look like. You could. But again, that's assuming we're doing FFT or waveform analysis, not just looking at scalar calculated values or saying, hey, the overall level climbed up So therefore, that failure mode must always be looseness. That's how the math is going to work in ML if you go down that path. This is really kind of an open book final versus taking a class and taking a test for a class that you never sat in one day or had the book. We're not going to let equipment fail that often. If we do, we will all be doomed a miserable failure. You know how your organizations put pressure on defect identification, letting something fail, or even defining that failure pattern repeatedly just to have enough data to be able to identify it in the future is absolute craziness. It's nonsense. But we get into, where does ML come into play? And again, I've talked about when a particular formula is not known or way too many variables exist to where we can't look at the data, get our mind around it, comprehend that, and understand the math. ML is a wonderful tool, and it does have a place and could be one of the most useful tools in Industry 4.0 or IIoT out there. And we'll get into why and how and where that is. Before we get into that, we kind of got to talk about, I think I've slipped ahead here. No, I didn't. Okay. We kind of need to talk about and really understand the PF curve. And there's so many different iterations out there, and people are putting a little bit of their own spin. There's I to P to F, I to D to P curves. But really, when we talk about condition monitoring and those analytics, we're talking about identifying point P. And as we've talked about, that's mostly a math problem. Getting good at finding the same defect over and over again is interesting, and the CBM world will pat themselves on the back. But it really comes down to eliminating point P and we'll get into that a little deeper. One of the funniest things that had ever happened, it's funny and disappointing on the same breath, is many years ago, I had an engineer working at a facility, and I was doing an audit, a technical audit, and this young kid comes running up to me and he says, "Man, I want to show you my database." And he was super proud because all of the foundational elements and everything required to really build a smart system, he had taken the time and databased all that information. And that's what he was so proud of. His comment to me was, "This bearing fails every 6 months. And sometimes it's a little earlier, but it never goes 6 months. But we have our database so good now that we can identify that. And man, we're not ever going to miss another bearing failure on that piece of equipment." And he's standing there looking for approval. And I said, "Well, that's wonderful. That's a very good thing. But are you out of your mind? We're going to celebrate the fact that we can continue to identify the same failure, but not eliminate it." And the kid was crushed. Now, he did do a good job. He did an exceptional job in his database and his setup, and he built his own little smart system that worked wonderfully. But we don't want to get good at identifying point P continually. It's not going to happen. So let's dive into this P to F curve. And for today's conversation, I'm really going to talk about the I to P to F curve. And I stands for the point in time where we install the asset or the components. Point P is the point in which I can identify an anomaly or a defect. And then F is when it actually loses function, or we have a functional failure. And everybody can argue what the word failure means. Good on you on that. But I think you get the idea. So after installations, our assets perform their function. There's all kinds of things that happen along the way that start to set this piece of equipment up for failure. And I don't have the slides, but a lot of you are familiar with the failure progression curves. And you understand that most things are random. In other words, failure is not linear in most cases. We have all types of early failures, late stage failures, but over 70% of the total failures are what would be classified as completely random. So along the way, again, we have speed changes, we have load changes, we have startups, changeovers, complete rehauls of the system, whether it be, in the automotive world, you're changing out complete production lines and moving equipment. All of these things happen, and there's a ton of data in there as to how the asset is running, what were the conditions. And again, based on your asset, some of those things change, and the process data along the way is more important than in other cases. But thinking about this I to P interval time that you see in the red line up there, we really need to be looking at the operational trends, the maintenance trends, what type of things happen. By utilizing all of the process and maintenance data, machine learning can be a very useful tool in identifying the cause of those recurring problems. That's where ML is wonderful, because there is so much data there that really picking out this event happens, then this happens, then the lack of something else happening ultimately results in point P occurring, is a wonderful use case for ML. I can't look at that data, and some of the best in the world can't look at that data and instantly tell you what the math equation is. ML and using different types of algorithms can come up with what is that formula for you. So again, we want to identify what's happening from that I to P time to eliminate point P, not get good at identifying it. Okay, so in wrapping up here, there's a lot of hype and buzz out there in our industry around what we're talking about. Start with your foundational elements. Understand your failure modes. Have failure-driven strategies. Whether that be, how are we going to perform maintenance? What are we going to apply condition monitoring to versus visual observations versus PMs versus whatever? Make it a failure-driven approach. When it comes to sensor selection, again, understand the failure modes, where they're going to propagate, understand that math equation, and is the sensor capable of providing you that data? That is how we should select our sensors and types of sensors. And utilizing a data and knowledge-centric approach to improve your results. It's really the synergy of and when it comes to AI, ML, and traditional domain knowledge, combining all that together to build your smart systems, to build your IoT networks and infrastructure, is going to pay huge dividends. And it's really not the tyranny of or, which means you decide, am I going to just be sensor agnostic or process agnostic? Make sure that we're combining the and in there to where we are including people, process, and technology to our benefit. So with that, I hope I can get back to see if we have any questions or any further info. I will stop sharing now. Maybe, if I can find you. There you are.
Awesome. All right. Well, Chris.
I think Paige helped me out and took me out of here.
That's my job, right? That's what I'm here for.
Nice work, Paige. You saved me.
I got you, Chris. We're in this together. All right, so let's take her home, everybody. So if anybody in our audience has any questions for Chris and you haven't already submitted them, go ahead, do so now in the question panel on your webinar screen. I know we got a few while you were presenting, Chris, so I'll throw those at you and we'll let the audience submit the rest of your questions. And guys, if you haven't already submitted your location, just a reminder to do that so that you're submitted as the final step in your entry for the great KIOT giveaway that we've got cooking. So, Chris, to get us started, this one's a little loaded and a bit open-ended, but I'll see where you take it. I'm curious. This person is wondering if you have any advice specifically from those sensor installation cases that you've worked. You mentioned this person's like, how have you done thousands? What is your biggest takeaway or advice that you have from someone going down the same path with sensor installation?
As far as the installation itself, the laws of physics have not ever changed, meaning you do know where to properly place a sensor. And I see a lot of installation guides from sensor vendors coming out that have epoxies that really aren't designed to do that. And keep in mind, when I'm attaching that sensor, I don't want to put a vibration insulator or isolator in the path of that vibration signal to my sensor. So sometimes I've had to really get creative in the field to figure out how to attach some of these sensors. I have seen some that actually come with double backed foam tape, and says just install this sensor anywhere on the motor and it'll give you all your valuable insights. Nonsense. It's cheating the tech. And when it comes to looking at amplitudes and some of the known values out there for alerts and thresholds, there's ISO standards and a lot of different things, and maybe your company has their own. If that sensor is not in the right place and it's not installed correctly, you're not giving the sensors a chance. They're not going to be able to identify those defects. So that's the biggest thing that I see going on right now is a lot of vendors are trying to make it so easy for the end user to install sensors so it doesn't get in the way, that they're getting really creative on how to put the sensors on the components, and they're introducing vibration isolators into the process. Not good. Great question.
All right. Awesome. Thanks, Chris. All right. So moving on to our next one that came in here. So this person is asking, oh, this is going to be an interesting one. So this person's asking, how do I get the rest of my team on board with understanding the marketing BS? Sounds like they're coming from a team that has some mixed feelings or approaches.
You know, it's tough. It's tough. And I keep saying, be the domain knowledge expert. And again, if we started from a failure mode driven approach to our design, you have all kinds of supporting data, if you will. I threw the buzzword salad out here because it's frustrating to me. It's terribly frustrating. A lot of us have spent a lot of time in engineering schools, in the field, doing these things, and we have a fundamental understanding. And although what we do is not, I won't say it's hard, but you do have to have a certain amount of knowledge there. So when we have people in an organization that are making the decisions on what sensors, what does IoT mean for them in the condition monitoring use case, be that domain expert. And it's going to come with a lot of education. Don't get frustrated by it. Just understand it quite simply. In effect, you're talking to people that don't have that level of education. They don't have that level of expertise. So it has to be predicated on your knowledge And always keep this in mind. The laws of physics and mathematics do not change. And as long as you have a failure-driven strategy, the truth is on your side. You just have to figure out how to communicate that to these folks. And that's one of the hardest things for me to do. I'm a terrible salesman. I've been referred to by my organization as the anti-sales team because I start throwing these technical facts out there, but they're not disputable. So hopefully your management team is open-minded enough to listen to what the math is based on science and the failure modes, what the technology is capable of doing. And it's your job to arm them with that information if they're going to make the decision. It's a tough one. It's a tough one. But whatever you do, don't let it get into an emotional conversation. The facts are the facts. The failure modes are the failure modes. The math is the math. At that point, it's not an emotional conversation anymore. It's based on fact and science.
I love it, Chris. Thank you. All right, these are some good questions, guys. Keep them coming. So I know we're a little shy on time. We're going to answer a few more questions. If everybody in our audience could stick around with us for another few minutes, we'd appreciate it. If not, you'll get a copy of the recording, which will include all of the questions and answers and all the good stuff. So, Chris, let's see here. Are you okay on time, Chris, to stick around for a few more questions?
Yeah.
Okay, awesome.
Hey, these are my people. I got all kinds of time.
Love it. Perfect. All right. So this next one up here, this person's asking, and I'm guessing based on this that they might be a student. So they're saying, do you have any recommendations about how to start out a career path as a rotating equipment engineer and in condition monitoring?
It's like the Nike commercial. Just do it.
I love it.
How to get started. Obviously I'm an old guy and have a lot of gray hair. And back in the mid to late 80s, early 90s, there weren't a lot of us out there. And there wasn't a lot of opportunity. Condition monitoring, predictive maintenance was something that organizations really didn't embrace. Today, it's very difficult to find any organization that doesn't have a staff reliability engineer and several analysts. I will say the most important thing if you want to get into an analyst role is it goes back to what we talked about in the presentation. Get yourself familiar with the assets. I grew up on a farm. People say, how do you know what you know about all this equipment? And I grew up on a farm and I grew up poor on a tobacco farm. We didn't run to town and get parts. There were no parts and there was no town. So tearing things apart to see how they worked I learned more than any university just by growing up the way I did. Don't be afraid to go get your hands dirty. You must know what those components are, what they look like, what are the internal workings. And there's so much data and information out there on Google, on the internet. Sorry. If you're going to work on specific asset classes, get very familiar with those asset classes. Not only those asset classes, but then understand their function and the systems they're operating within and understand those failure modes. If you learn those things, you are 90% you're ahead of 90% of the people on the planet. That's where I see a lot of failure happening here. People want to shortcut. They want to be a textbook analyst, and that's fine. The textbooks and the math and the logic that I talked about so much here are important. You must know it. But if you don't understand how it can fail and what failure looks like, you're swimming upstream. As far as opportunities, man, it's hard to not go to a job board right now anywhere on the planet and not see someone looking for condition monitoring people. And I will tell you that us old guys are retiring. The average age of a maintenance engineer in the US anyway is 55 years old. So we're going to be leaving the industry, hopefully by choice soon. in retiring, and there's a huge void out there right now. There are people begging for folks to get into this space. So for you young kids and you people that are just starting out in your careers and wanting to go down this path, the opportunities are immense. Keep your head up, keep your nose clean, study, understand the things that aren't in the textbooks necessarily. A guy I work with told a story that he had an engineer working on a heat exchanger, and it was a young kid out of university, and they were going to do a walk down to get the attribute and some of the information. And the guy looks at him and says, I can tell you the thermodynamic capabilities of this heat exchanger. I can design it from soup to nuts, but I don't know what one looks like. Can you tell me where to go see one? I'm supposed to walk this thing down and I don't know what it looks like. So don't be that person. If you want to get really good at this space, dive in there, tear things apart. And it doesn't matter what things. I had to tear apart a gas grill this weekend, or a pellet grill that wouldn't feed in there, to find out that the motor was mounted really bad on the little gearbox that turned the auger in there. You can learn a lot from just tearing things apart. And don't be afraid to go out there and play and tinker, especially on things that are broke. You're not going to break them any more than they're broke. Figure it out. Figure out how things work. But get that knowledge. People that have that knowledge are going to be invaluable in the next 15 years.
I love it. Just mess with all the broke things. Love it.
Dude,
Great advice. It's great advice. I love it. All right, so moving on here, and keep the questions coming, guys. I think we're going to answer another question or two, and then if there's any more, we'll be sure to share those with Chris, and he'll circle back with you once we're all wrapped up here. I think this is an interesting one. So it's a follow-up to the giveaway, Chris, but they're asking, what exactly does a maintenance assessment look like? What could they expect from that experience?
Yeah, great question. I'm glad somebody asked it. Yeah, the maintenance assessment is kind of buzzword salad, right? So what we would do, we actually come in and we look at your existing condition, meaning what percent of your assets are being covered by condition monitoring, by PMs, by operator care activities. We're going to look at how much and how well in each of those areas. Then we're going to break it down and look at the failure modes within your asset base and look and see what percent coverage you have of those, whether it be PM, PDM, operator care. So we're going to look across the board on that, and then let you know where you fall as far as quartile coverage models on condition monitoring coverage, planned maintenance versus emergency maintenance, and give you a really good idea based on some benchmark data that we have where you fall in your particular industry vertical, then make specific recommendations to get to that next level while we work with you in understanding, where are your pain points, where's your organization driving to, what do they feel like good looks like, and we're going to give you an assessment of where you are today, of what really you need to do to get there to that first quartile performance.
All right. Well said, Chris. All right. So then we've got another question up here. This one's going to be our last for today, guys. But again, use the time. I know I'm hearing, Chris, we're getting a lot of positive reactions, a lot of claps from the audience. So thank you very much for everything. But we're going to wrap it up with one more question. If anybody else wants to use the time to submit more, go ahead. So let's see here. So this last one is a classic. So they're asking for some clarification in the difference between IIoT and IoT.
It's in the spelling. So IIoT is industrial Internet of Things, right? IoT is Internet of Things. So when we think about IoT in the commercial space, it's really about what data, what telemetry we can get, whether that be someone wearing a watch that counts how many steps you take, to your heartbeat, to your travel patterns, to what you're buying at the grocery store. when we throw the word industrial in there, it's really about industrial data. We're talking again about process measurement, process improvement, and obviously the condition monitoring side that we focused on here a little bit. But it's the difference is where I'm applying it. It's whether it's in your general world or your work world, you could think of it that way. Again, I'm terrible on acronyms and buzzwords. I despise most of them. I laugh at some of them. But the real difference is we're talking about our industrial infrastructure versus outside of that world.
All right. Awesome. Well,
And,
Chris,
you can also think of
go
that
ahead.
of B2B versus B2C. For you marketing, sales folks, that's really the difference.
I love it. Well, Chris, where can people find you? Where can they get in touch with you? Where can they learn more?
Great question. We do have a website. You can go to k-iot.com. We are on LinkedIn. A number of different ways you can find us. We're not hard to find. Just look up Coyote and you'll get to us.
All right, beautiful. Well, anything else that you wanted to add, Chris, before we wrap things up for today?
No, not really. I really love the question from how do I get into this space? There are some things that Coyote actually is looking at right now to offer some mentorship type programs to help to help these younger people get in. Manufacturing is going to have a crisis, and we're kind of already seeing it. The getting new, fresh talent, new minds into this industry, and I'm really concerned about the future of manufacturing, specifically around the maintenance arena. It's anything we can do to help get new folks in, get them excited, get them mentored, get them trained. Be glad to help any way we can on that.
Yeah, we'll be sure to connect you with the person that asked that question, Chris. It's definitely a large opportunity that's already happening somewhat, but it's going to get that much more escalated in the coming years. So it's wild, but that's great that you guys are going to be doing that. So thank you for today and for doing that, because it's so important for everybody to have that mentorship. That's invaluable, honestly.
Yeah. Well, thanks for having me. This has been awesome. Hope you guys get something out of it.
Perfect. Well, Chris, I think I'll be seeing you next week. There's an industry conference in Orlando, so I'll be seeing you there, and maybe a few of our listeners will be as well. I think you have a presentation, right?
I am doing at least one presentation and moderating a couple panels at that event. So if anyone's there, look us up. Be glad to chat. Awesome. Be glad to meet new people.
Perfect. Love it. Well, I'll see you there, Chris. And thank you again for your time today. And now for those of you in our audience, so if you haven't already submitted your location, go ahead and do so, please. This will be your last chance, the final step in the big Coyote giveaway. So enter your location. And again, you'll find out in 48 hours if you've been chosen the winner. And we'll also make a huge splash of it on social media, so you'll see the results that way too. But that being said, everybody, just a few notes here today. So as a thank you for attending WOW 11, we're pleased to provide you with 50% off of your conference pass to any of the CBM and Reliability Connect live training conferences. We have a few more stops on our tour for this year. So we're coming to Mexico in a few weeks and then to Perth, Australia at the end of the year. So feel free to use that code WOW50 to reserve your seat if you're interested in attending a live learning session. Or a few with us. Those conferences include certification opportunities, case study sessions, hands-on workshops, a whole variety of things, and great learning and networking opportunities. So I hope to see you there. You can visit MobiusConnectConference.com to learn more about the live conferences, or we'll include a link for you in the follow-up email after this webinar, so you can be on the lookout for that there. And then coming up next, we're not done for today just yet. So we have a great session coming up in about 45 minutes from Allah Omar, how to build a risk-based failure management strategy. So if you haven't already signed up and you would like to attend Allah's session, jump back to the attendee hub. You don't need to do anything special to register. You just click that you'd like to join the session, similar to probably how you did for this one. You can jump on in, tune in with us live. And if not this session, hopefully we'll see you again in another WOW session this week. And then just one final reminder. So be on the lookout for that email from us, which will include your access to the on-demand library for WOW 11, including Chris's session and all of the sessions from this week. And also in that email, your certificate of attendance will be attached. So be on the lookout for that. We love to see those up on social media. Feel free to share your certificate of attendance for today's session. Tag Chris, tag Coyote, tag me, tag Mobius Connect, tag everybody. We love to support you along in your continuing education journey. So be sure to share those there. And if you're interested in engaging more with industry professionals like Chris, feel free to jump up to Mobius Connect at mobiusconnect.com, create your free profile. You can engage on the live feed, forum discussions up on Mobius Connect. You can also follow us on social media at Mobius Connect to stay up to date with all the latest community happenings. And then if you guys have any questions, anything about WOW 11 that you have questions about or suggestions, any feedback, any topics you'd like to hear about in the future, or if you'd like for us to make an introduction to the guys at Coyote, we'd be more than happy to do that. You can email myself and our team at info@mobiusconnect.com. But thanks again, everybody, for joining us. Like I said, hopefully we'll see you again in another WOW 11 session. But in the meanwhile, stay safe, and we will see you next time.